So this is our final project for our embedded systems lab. We had to design a PCB, and we decided to take apart an old Game Boy, throw away all the old hardware, which looked like this, and put our own hardware inside. We recreated the original Mario Brothers for the Nintendo Entertainment System and put it inside a Game Boy. So talk about some of the features here. We have all the push buttons, we have a volume knob, and the original power switch. We also added a USB connector so we could charge the battery while we're playing if need be. So I'm going to do a run through real quick and then I'll open it up and show you all the components inside. So we recreated the first level. Some of the graphics stuff includes a double buffer system which allows for seamless graphics display. We have Mario as a transparency item which can be drawn over the bitmaps. We have sound effects going on top of the music. The music output is similar to a MIDI player. We transcribed the sheet music and figured out which notes to play. There we go, some fireworks. We beat the level. Alright, so we also added a bonus stage, but for now I'm going to open up and show you what's going on inside of here. Alright. Okay, so I unscrewed it. I'm going to open it up. As you can see, we use this screen here. It's a little smaller than the original screen, so we 3D printed a little cover here so it looks more natural. Pull out the PCB, disconnect it from the battery right here. And here's the battery charger I was talking about before. The little small battery here, a LiPo battery. So it sits inside the case here. We had to do a measure twice, cut once thing to make sure everything fit perfectly. Make sure all the switches were in the right place. So our board uses two microcontrollers. They're TI's TM4C123 microcontroller. We have a master and a slave set up. So this is the master, which drives all the graphics and accepts button inputs. And then this is the slave, which controls all the music outputs. The two microcontrollers communicate using UART. The master will tell the slave which song to play, and the slave just waits and accepts those inputs. For graphics display, we use a pre-standard library, and we had to create a lot of our own library items too to make this work. We laid out all the capacitors and bypass capacitors and the power setup here. We were able to use the original power switch from the Game Boy here. We have a buck boost regulator, which gives us a steady 3.3 volts for run mode. We added a volume control potentiometer. You could flash the chips using a JTAG programmer. If you come onto the slave side, you can even remove the screen. And we have, it's a 12-bit DAC. The microcontroller sends the DAC which value to play for sound, and then it runs through an audio amplifier which gets passed to the speaker. And I believe that's all. All right.